Today I'm going to discuss the new lesson which is rotational dynamics. So under rotational dynamics, we will see what is torque or moment of force. So when you say torque, it is just the turning or the rotating effect of linear force, or it is the angular or the rotational equivalent of the force F. So when you say torque, it is the rotational effect or the rotational equivalent of the linear force around a given axis or point. So if you have a number of forces which is acting in a given object, there may be a turning effect or a torque which is acting in a given body. So when several forces act at different points on an object, they can have a turning or a rotational effect. So now, mathematically, how to find torque or the rotational equivalent of force, we call it moment of force. So here, the torque tau is the same as the cross product of the two vectors, which is r and f. R cross with f, which is the same as magnitude of r multiplied by magnitude of the force f times sine theta in the directions of n, where n is the unit vector. So tau is the torque, where r is the distance from the axis of rotation to the point of the force. ስለዚህ r ስንል it is the distance from what? The axis of rotation up to where the force is acting. ስለዚህ r ሁሌም የምትወስዱት ፎርሱ አክት ካረገበት ፖይንት እስከ axis of rotation ያለውን ዲስታንስ ይሆናል። where f is the linear force or the force which is acting in a given body is a system ላይ act የሚያደርገው ፎርስ ይሆናል። where theta is the angle between the two vectors r and what? The linear force f. ስለዚህ በቀላሉ ይህን ኢኩዌሽን በመጠቀም ቶርኩን ወይንም turn rotational effecቱን ማግኘት እንችላለን ማለት ነው። If it is all about the general formula of the torque or the rotational equivalent of the linear force, how to find the net moment or the resultant moment or the resultant torque which is acting in a given system. So the net torque net is equals to the torque tau which is acting in the directions of counterclockwise minus the torque tau in the directions of what? Clockwise. ስለዚህ የተለያዩ ፎርሶች አንድ ሲስተም ላይ አክት የሚያደርጉ ከሆነ ለምሳሌ እዚህ ጋር we have around what? 4 forces አይደል እንዴ? አራትም ከዛም በላይ የሆኑ ፎርሶች አክት ሊያደርጉ ይችላሉ። So we have to analyze which force creates a counterclockwise moment and which force creates a clockwise moment. እነሱን አናላይዝ አድርገን ከለየን በኋላ we have to sum up what? All the moments which is acting in the directions of clockwise and in the directions of anti-clockwise. እነሱን ከደመርን በኋላ we have to subtract what? To find the net moment, we have to subtract the two moments, summation of moment or the summation of the torque which is acting in the directions of counterclockwise minus the summation of the torque which is acting in the directions of clockwise. ስለዚህ የተደመሩትን ሁለቱን ማቀናነስ እንችላለን ማለት ነው። Most of the time the torque which is acting in the directions of anti-clockwise or counterclockwise taken as a positive and clockwise moment as a negative. ምናልባት አስፈላጊ ከሆነ መቀየርም ይቻላል። ዋናው ነገር ከሁለት አንዱ ማይነስ መሆን እንዳለበት ማወቅ ይኖርባችኋል ማለት ነው። ስለዚህ if we have a system or a given bar with a different force which is acting on it, first of all we have to analyze which force creates a counterclockwise moment and which force creates a clockwise moment. Okay, let's see the examples. We have 4 forces which is acting on the bar. So the bar of length is 4 meter. አጠቃላይ የባሩ length 4 ሜትር ነው ተብላችኋል. And we have 4 forces which is acting on the bar. So F1 is 20 Newton at an angle of 30 degree, and F2 also here which is 10 Newton at an angle of 60 degree, and F3 is 15 Newton at an angle of 45 degree from the bar, and F4 is acting at one corner of the bar which is 8 Newton which is acting at right angle from the bar. ስለዚህ እነዚህ ፎርሶች ተሰጥተውናል። ቶታል ሌንግዙ 4 ሜትር ነው ተብላችኋል። ስለዚህ ከአክስ ኦፍ ሮቴሽን ወይም ከአር እስከ ኤፍ2 ድረስ ያለው ዲስታንስ 2 ሜትር ተሰጥቶናል። እንደገና ከኤፍ2 እስከ እዚህኛው ኮርነር ድረስ 1 ሜትር ነው ተብላችኋል። ስለዚህ አጠቃላይ 4 ሜትር እስከሆነ ድረስ የኛው 2 ሜትር ከሆነ የኛው 1 ሜትር ከሆነ እቺኛው 1 ሜትር ትሆንልናለች ማለት ነው። so by using this distance from the axis of rotation to the point of the force we can manage the torque or the turning effect. so how to find the net torque or the net moment at point r? ስለዚህ አክሳችንን እዚህ ጋር ስናረጋው ቶታል ወይንም ኔት ሞመንቱ ወይንም ኔት ቶርኩ ስንት ይሆናል ነው። ስለዚህ to find the net torque which is acting at this point r ላይ ያለው ኔት ሞመንት ለማግኘት we have to identify which force creates what? a clockwise moment and which force creates anti-clockwise moment. ስለዚህ እሱ መጀመሪያ በደንብ ከለየን በኋላ ነው ወደ ካልኩሌሽኑ የምንሄደው። so mathematically torque net is equals to the summation of the torque in the directions of counterclockwise minus the summation of the torque in the directions of what? Clockwise directions. So torque 1 is equals to R1 times F1 times sine theta, where R1 is, where F1 is 20 Newton. ስለዚህ R ምን ብለናል እዚህ ጋር? The distance from the axis of rotation to the point of the force. so our axis is here. አክሳችን r ላይ እስከሆነ ድረስ ወይንም ኔት ቶርክ ፈልጉ የተባልነው r ላይ እስከሆነ ድረስ r ሊሆን የሚችለው ከዚህ ፖይንት እስከ f1 ያለችው ዲስታንስ which is 2 meter plus what? 1 meter. ስለዚህ 3 meter multiplied by the force which is 20 newton times what? sin theta, sin 30 degree. ስለዚህ torque 1 is equals to 3 times 20 times sin 30, 0.5 multiplied by 20 which is 10 times 3, 30 Newton meter in the directions of clockwise or anti-clockwise. Ziga, if the system is pivoted at this point, F1 creates what? Anti-clockwise moment. ስለዚህ F1 at an angle of 30 degree በዚህኛው direction act የሚያደርግ ከሆነ the system or the ball will bend in the directions of what? Anti-clockwise. ስለዚህ this is a counter-clockwise moment. counter-clockwise መሆኑንም ለይተናል ማለት ነው። torque 2 is equals to R2 times F2 times sin theta, where R2 ከአክስ ኦፍ ሮቴሽናችን እስከ F2 ድረስ which is 2 meter multiplied by 10 Newton. 2 meter times 10 Newton times what? Sin how much degree? 60 degree. sin 60 0.86 ሲባዛ በ10 8.6 ሲባዛ በ2 torque 2 is equals to 17.2 Newton meter. So in which direction torque 2 or the second force creates a moment? ስለዚህ እዚህ ጋር ስናይ already the bar is pivoted at this point. ስለዚህ አክሳችን r ላይ እስከሆነ ድረስ F2 acts downward at an angle of 60 degree አይደል? ስለዚህ F2 ወደ ታች አክት የሚያደርግ ከሆነ the system or the bar bends in the directions of what? Clockwise. ስለዚህ F2 creates a clockwise moment. This is a clockwise or the system bends to the right. እሺ what about torque 3? torque 3 በF3 ፕሮዲውስ የሚሆነው ነው። አሁን እዚህ ጋር you know torque 3 is R3 times what? F3 times sin theta አይደለ? sin theta. ስለዚህ እዚህ ጋር እንደምናየው F3 is acting at a point where the system or the bar is what? rotating, right? ስለዚህ R 0 ነው ማለት ነው። R 0 ሆነ ማለት 0 multiplied by this which is 0, which means that አሁን 0 ነው ማለት torque 3 0 ነው ማለት at this point ወይንም F3 axis of rotation ላይ እስካለ ድረስ ምንም አይነት turning effect ወይንም torque produce ማድረግ አይችልም ማለት ነው። ስለዚህ let's proceed to the next torque which is torque 4 which is R4 times F4 times sin theta, where R4 is the distance from the axis of rotation up to where the force is acting ስለዚህ አጠቃላይኛ 3 ሜትር ከሆነ እቺኛው 1 ሜትር ትሆንላለች ምክንያቱም አጠቃላይ የቶታሉ የባሩ ሌንግዝ 4 ሜትር ስለሆነ ስለዚህ 1 meter multiplied by f4 which is 8 Newton times sine how much degree? Sine 90 degree. Sine 90 is 1 times 8 which is 8. If it is all about torque 4, so f4 creates a clockwise or anti-clockwise moment here. ስለዚህ አሁን አራተኛው ፎርስ clockwise moment ነው ወይስ anti-clockwise torque ነው ፕሮዲዩስ የሚያደርገው የሚለውን ለመለየት our axis is here or the system or the bar bends or turns at this point. So if it is pivoted at this point, F4 creates what? A clockwise moment. ስለዚህ torque 4 also creates what? A clockwise moment or torque. ከዚህ በኋላ summation of torque in the directions of counterclockwise which is what? 1 አንድ ብቻ ነው አይደለ? counterclockwise torque ያለን እዚህ ጋር torque 1 ብቻ ነው which is 30 Newton and the summation of the torque which is acting in the directions of clockwise is what? torque 2 እና torque 4 already torque 3 0 ስለሆነ ስለዚህ ስንት ይሆናል 17.2 ኦኬ ስለዚህ 17.2 Newton meter plus 8 meter 8 ሜትር እሺ ስለዚህ 17.2 እና 8 25.2 ኒውተን ሜትር in the directions of clockwise ኒውተን ሜትር ይሆንልናል ማለት ነው so the net moment torque net is equals to the summation of the torque in the directions of counterclockwise minus the summation of the torque which is acting in the directions of clockwise which is 30 Newton meter minus 25.2 Newton meter which is the same as 4.8 Newton meter. In which direction the system bends already net torque አለ ማለት the system bends or turns at a point ስለዚህ net torqueአችን 4.8 in the directions of what? Anti-clockwise or counter-clockwise. ስለዚህ ሁሌም ቶርክ ላይ በደንብ ማስተዋል ያለባችሁ እያንዳንዱን ፎርስ መጀመሪያ በደንብ መለየት ከዛ in which direction the force creates what? A moment or rotational effect. እሱን ከለያችሁ በኋላ you have to sum up the moment in the directions of clockwise and anti-clockwise. እነሱን ከደመራችሁ በኋላ ማቀናነስ ነው ማለት ነው so this is all the time out here for today ስለተከታተላችሁኝ አመሰግናለሁ ጥያቄ ካላችሁ ኮሜንት ላይ አስቀምጡልኝ ሰላም ሁኑ